Exercise 7. The following data were obtained from a study of the times required to conduct a consumer test panel study. Determine the normal and full crash duration and costs, and determine the least cost for the full crash. So in this case, you can see that the data for certain activities have been given to you, and their crash cost and schedule, the normal cost and schedule has been given to you. The activities are given in event number terms, so it will be better for our calculation purpose that we can name these activities as A, B, C, D, E, F, G, H, and I. And based on these event numbers, we can also specify their immediately preceding activities. So event numbers start from 1, so there are no immediately preceding activities for A and B. For activity C, the event number is 2, so 2 is the ending event for this activity, so its preceding activity will be A. So similarly for 3, 4, the 3 is the ending activity for activity B, so event for activity B, so B is the preceding activity. For this activity it's 2, so it will be A. For this activity it is 4, and the 4 is ending activity for these two activities, C and D. So therefore for F there are 2 immediately preceding activities. For G, so for G it's also C and D. And for H, 6 is for this E and F. And for I, the immediately preceding activity is G. So once we have this data, then it is easy to draw the activity on node network diagram. So I can draw these nodes A, then B. These are the two starting activities. Then C from A to C, B from B to D. E from A to E. And then F is from C and D. And G is from also C and D. H is from E and F. And I is from G. I is from G. So two terminal activities are H and I in this case. Now we can enter their normal time durations over here. So 5 ECD, sorry, CD, C is 10, D is 7. So here I have entered the duration of the activities in these nodes. Now I can do the forward pass and backward pass calculations. So 0, 5, 5, 11, so 5, 15, 0, 5, 5, 12, so 15, 26, so it should be 26, 31. So the forward pass has been completed. Now one can do the backward pass as well. So the backward pass calculation has already been completed. So which shows that the critical path is A, C, F, H, A, C, F, H. So A, C, F, H is critical path. A, C, F, H. So the duration of the project is 31. So this is, which is also the sum of the duration of the activities on the critical path. 5 plus 6, 11. No, sorry, 5 plus 10 is 15 plus 11 is 26. 26 plus 5 is 31. Okay, so the normal duration is 31 days. Okay, normal duration. Normal duration 31 days. The normal cost will be the sum of these costs. Actually, these costs are the given in thousands. Okay, so if you add up all these, so then it will be 7, 13, 16, 24, and 7, $31,000. $31,000. Okay. For the crash cost, we have to redraw this schedule, but all the costs will be the crash costs. Okay. So then now I will redraw this schedule with crash costs. So this is the same network with all the durations for the activities as crash durations. So for the same network, the forward pass and backward pass calculations can also be performed. Okay, so this is the activity on node network diagram with all the durations as crash duration. And as you can see that the crash duration is 14 days. So the crash duration is equal to 14 days. 14. Actually, they use the weeks. Okay. So for the crash cost, you need to add up all the given crash costs here. So since all these costs are given in thousands, and if you will add up, you will get $53,000. Okay, so these are the answers for determine the normal and full crash duration and costs. For the answer of the last part, determine the least cost for the full crash. So since this is the Full crash means that all the activities have been crashed here, whether we really need to crash those activities or not. So this will mean that we have unnecessary, in this full crash there will be unnecessary cost increase. So what is the least cost which is needed for crashing this to 14 weeks? So for this we can look at those activities which have the slack, and we can remove their slack if possible. So for example, by removing this slack means that we will increase the duration, and by increasing the duration we will uh, decrease the cost. So for example, if this is the activity A, the normal time is 5 days and the crash time is 3 days. So for if in this situation, if this is 3 days, then if its duration was 4 days, then the cost will be less. Okay, so this thing can be checked for other activities. So by looking at this network, some of those activities can be found which can be increased to with their with some of the those activities can be increased in durations. So for this we need to find the crash slope for different activities. So in this case, the crash slope for first activity A will be like you will take the crash cost, which is 6, and then subtract from the normal cost. 6 minus 4 is 2, divided by 5 minus 3 is also 2. So the crash cost will be $1,000 per week in this case. So which is just represented as, which will be represented as one per week. So maybe I can add the slope values over here. So it will be 1 for this. For this it will be 5 minus 3, 2. 2 divided by 4 is 0.5. And similarly, we can calculate for other activities. So the crash costs are, so the crash cost slopes are calculated and represented here. Okay,